So we move on with our DevFest and greet our next speaker, Christoph, with some applause again, please.
Hey, thank you. So we got 25 minutes or so till the coffee break, and I hope my voice doesn't crack till then, because, it's a bit rough today. Nevertheless, I'm Chris, as he just said. I'm part of the Spring Data team, and I want to show you what we did for the currently release, or what we're planning. So actually, this is a safe harbor statement. I guess everybody's familiar with that, so you shouldn't trust anything I say today, because it might contain some forward-looking information and stuff like that. So please don't base any business decisions on that. But you know what? We actually released Spring Data 2025.1 yesterday, so we stayed up late to just have it ready for this conference. No, just kidding, but we had the release cadence yesterday. So it's out there, so almost everything I show you today is already available despite the Spring Boot part. So Spring Boot will release next week, picking up the data release. All right, Spring Framework 7, by the way, for the Java developers in here, is already available since Thursday. So we just released the day after. Here we go. Java developers in the room? Yes, quite a few. Familiar with Spring Framework? Almost everyone. That's great. So Spring is, for those who don't know, an application framework that lets you build Java applications really efficiently by just letting you focus on what matters, like the business logic that you're trying to develop, and not so much which library do I need to pull in and how do I set it up correctly, but we can help you with that. We have integrations for it. And what you typically do when you want to develop a Java application with Spring, you just head over to start.spring.io, pick your favorite language like Java, some pick Kotlin, not so many Groovy these days, then your favorite whatever build system, may it be Maven, may it be Gradle. Of course, the latest Spring Boot version, which is RC2. So as I said, forward-looking next week, hopefully we'll see the GA release, and then give it a name, select, hopefully if you are interacting with the database, your favorite database with Spring Data integration, like we have integration for Cassandra, we have something for Couchbase, there is something for Redis, so pretty much everything. For this typical SQL stores, you can choose either JPA backed by Hibernate or Eclipse Link or whatever OpenJPA provider that you prefer to use, or just go for plain JDBC if you prefer writing your select statements on your own. Perfectly fine with that. We just help you with all the connection pooling and stuff. All right, and once you have this, then basically we help you create DDD, domain-driven design, repository-style interfaces. So what this does is basically you define your Java interface, and then you put a bunch of methods in there. And the thing is, you don't have to necessarily provide the implementation for it, but what Spring Data will do, it will go ahead and just look at the repository interface, and then wrap it with a Java proxy, and then inspect the methods and all the such. And you can choose from predefined repositories like typical CRUD applications where you have predefined save and find methods and things like that, or you just write your own stuff in there, and we'll go ahead and inspect the method names and then do some splitting there, which I'll explain just in the next couple of slides. And then we'll just go ahead and use a default implementation that knows, all right, this is the method, this is the part that we need to do, so match against certain criteria. So that's how it works. And then the proxy just takes the method name, sees, all right, there's maybe a custom implementation that you provided yourself that you want to bake into the repository, and then it just delegates. That's pretty much all it does. All right? And we do this for all the stores. So we have store-specific implementations for like MongoDB, Redis, Cassandra, you name it. And for the repository methods, for the ones that aren't predefined, but your custom methods, like you want to write a find by name, we basically inspect your method and just look at the return type. So there is a list. So you're probably interested in more than one entry. Like you could have one, but in this case, you want to read multiple ones. Of course, of type employee. Then we got an operation keyword. So which indicates this is a method that we should look at. There is a couple of those, like search. If you don't like find, you can use search, or get if it's just one. So we'll recognize this one. And then, of course, the property name that we should match a given argument against. And that's pretty much all it does. So this is the tree that we're building, and then we derive the query from. All right. And once you understood that pattern and how it works, and you know that there is a proxy in place, it's pretty easy to write your query methods that are specific to your domain. Like you can combine specific criteria using the AND keyword. You can do geospatial search if the underlying store supports it. Just give it a polygon and it will just get the shape of it and then find the people within there maybe. Or just select a single one by a specific criteria. You could even page through your database entries, like so you want to read and go from page to page. Then we got certain pageable types, and it will give you a page in return. It will tell you, hey, there is a next page, and you can then just pipe in the next pageable, and it will just go ahead and all that stuff, and it will tell you how many entries are within your database matching that criteria. There is another we got, like for MongoDB specific. MongoDB supports something like that's called GeoJSON, which is a specific format. So there's support for this as well. You can stream data if you want to. If the data store supports streaming, like some SQL data stores or Cassandra or MongoDB, then you just can go ahead and just use a Java 8 stream, and we'll make sure that we close the stream once you are done with it. Like sometimes the cursor stays open, and in this case, we'll take care of closing it so you don't have to do it yourself. Then this is a specific thing for MongoDB. This is like you could have event streaming. And in this case, this is called a tailable cursor, like you always read at the end. And that one keeps open, which is more like a reactive flow element if you want. Like you could then have just one HTTP endpoint and multiple clients connecting to that one and then just streaming out the data in an event stream if you want. Right, of course you can do counting and things like that. And typically all of this just works fine, and you start your application and it will show some logo and the version you're using and the Java version that you're running and the PID and stuff like that. And it just works until it doesn't, which typically happens on a Friday afternoon when you're having pizza with friends, with family, or whatever you're doing yourself. Then this typically happens, and then you basically get up, put your phone out, and then try to make sense of what this tries to tell you, because Spring Data is an application framework, not trying to support just your application, but lots of applications. So this is not, there's a lot of indirections in there, and departures and deparsing. So if you ever try to debug an error message in there, then this is like, not so much fun. All right, so we could do eventually better. And this is something that we did with the recent release. So we're introducing ahead of time repositories for Spring Data JDBC with this release, JPA with Hibernate, MongoDB, and Apache Cassandra. So those are the first few stores that will get this feature. And all you have to do to enable it is basically build with the flag enabled, which says Spring AOT ahead of time enabled true, and this will tell the infrastructure at build time to do certain things to make to turn the repository interface that doesn't necessarily have an implementation because it's derived at runtime into actual source code without an AI in the background, hopefully, so it's reproducible. All right, so when we look at a demo application, pretty simple, just straightforward, using MongoDB as a document store. Then we have a source repository that may or may not look like this. So you got a bunch of methods for using different return types. You may have annotated queries because it was a bit too complicated to derive from the method name, so you put some custom stuff in there, which is perfectly fine. We'll do parameter replacement for placeholders and stuff. For MongoDB, you can have things like that are called aggregations, which is like a pipeline of steps that the database follows to then produce the output. Like in this case, it matches a certain criteria, and then it selects parts of it and does some, what does it do? Some conditional operations on an array. You don't have to understand it right now. It's like, it's a pipeline that needs to be executed, has different treating. And of course, if the store supports it, with the recent release, we added also a vector search annotation that makes it easier to just do vector search on your database for RAG or whatever use case that you have. All right, so once you build with this flag enabled, we'll just generate something that's called user repository implementation __ AOT repository, so that you know this wasn't contributed by you, but it's a generated thing. And when you think about it, the proxy that we had before, that all that stuff will still be in place. The only thing is, at the bottom, basically, we'll add this implementation, just like a custom extension that you could bring in, like you could add in, mesh in your own code. The AOT implementation will just be treated the same. So if the signature matches, then we'll just delegate to the implementation once a method on the proxy is invoked. So just the same stuff as before. And then when we look at the generated code, obviously it's add generated just to indicate this was created at build time. You shouldn't edit it. Of course, things in there might change. Not too much in the coming years, but we'll see how it goes. And then you'll find all the methods that you declared within your repository coded out like when you would code them yourself. So this is pretty simple stuff in here. Like you have a certain, we translate the method with the part tree, as we would do normally, into a query string. Then we bind the parameters, execute the find operation, and then do some result transformation if necessary. That's what happens here. It can be a bit more advanced, depending on the use case and what you're trying to do with your query method. Like you saw the aggregation before, like this huge string. So we take it in here, we split it into the stages, and then we get some special treatment for, let's say you want to sort stuff by certain criteria, or you want to limit the results. So these are the special input parameters. And then we just generate, if it's sorted, then do certain things and make sure that we map the fields of the result against the return type, which may be different from the domain type that you're querying against, and things like that. And or if the result is limited and you just want to see the first 10, then of course we'll take the limit and apply it accordingly. And for vector search, obviously, since it's a new feature, it will be in here as well. Vector search is different to every store, so the code, of course, for MongoDB will look way different from when you're using vector search with, let's say, Hibernate Vector and JPA. So that's two different worlds, like the data stores are. Like you cannot swap out MongoDB against a SQL store, nor would you change the driver from Hibernate to MongoDB. That just doesn't work, and that's not the intention here. But just stay as close as possible to the underlying data store and make sure it works. All right. And then, once we have all this generated and packaged up into our application archive, we need to tell the infrastructure to consider the AOT-generated bits. Because typically, you could pre-generate them and then just start the application. You wouldn't see any effect because the Spring Framework itself doesn't know it needs to apply the AOT-generated code. So you need to set this flag, which also helps if you want to test your application. So you can start it with and without the flag and see if it behaves identical. Right, and then It typically looks like this, and I want to highlight that it's telling you, first of all, it's using AOT contributed code. Then there is a line missing, which tells you, because normally when you spin up the application, it looks at all the repositories and identifies them and spins them up, which isn't necessary any longer, because at build time, we already know which repositories are defined in your application, so we can skip the step. And overall, the startup process is faster and consumes less memory, which is a good thing. But we didn't change our application, right? So the dinner will still be ruined by this nasty error message. The only difference this time is there'll be a pointer in the stack trace where you have to look, and you'll be able to hopefully find the error faster. So I hope this helps. So debuggability is really key here. But it's not only about debuggability, right? But we also, since we are inspecting already your repositories at build time, we can have some tooling support and some metadata. So first of all, we can extract metadata at build time. So we can provide you with a JSON file that contains the derived query metadata, so you'll get that. And then you don't necessarily, you can put it into the documentation even. So, and then you don't have to look up the method in the source code, but you can potentially even look at the documentation and see, oh, this method went wrong. Let me see, this is the SQL statement that got executed. Oh, there's an error in there. Now I understand, right? And it helps IDE vendors to just pick up the JSON file and then helps you display information while you are developing in your IDE, so it can already inline some of the code snippets that get executed later on. So we're working with folks from IntelliJ IDE, as well as VS Code and our very own Spring Source tool suite to just get that in there. We already have previews for all three of them. All right. We saw already that the application startup was a bit faster, just using this AOT, because we can bypass a few code paths. And if you ask me, application performance is like cars, and faster is always better to me. So we saw it's faster, but when you're familiar with the JVM, which I think pretty much everyone in here is, then you know that till your code gets executed, there is a lot of ceremony going on actually before we come to that very point where stuff that you wrote is being executed. And since Java 24, we got, even before Java 24 with CDS, there's a little help in there that makes the application startup, like reaching that point where your code is executed faster. So it helps with class loading and basically delinking, so it can just faster serve your classes, initialize them, and so on. All right, so how does it work? I mean, obviously, such generated repositories, since they're source code, are a perfect fit for those types of analyses, because we don't do anything at runtime anymore. It's all at build time, so the JVM can see the code and do stuff with it. And so this is from the log file, so you can enable log for this cache, and then you see you can serve it directly from the shared objects files. So this is already initialized and linked fully this AOT repository. Makes startup pretty fast. But nothing in life is for free. So is like creating this file and making your application ready to do this. So first of all, what we need to do is to leverage the support is we need to optimize our application for it. Like if you look at the typical Spring Boot application, it will create this Uber jar that you can automatically start, and it will contain all the libraries and classes within this Uber jar, which isn't an ideal fit overall. Like if you look at efficient deployments, then you know that reading from a zip archive has a performance impact, obviously, because you have to extract stuff. So to really leverage Project Laden and all the features in there, we need to bring it into an optimized form to reduce the startup time, right? So if you're developing with Spring and are using Spring Boot, then we get something built into the execution, which is called the jar mode, and you just tell it to extract your application. And what this does is it just takes the lib directory and puts it outside of the jar in another directory and alters the manifest file and does a couple of other things so that the overall jar gets a little bit smaller and just optimized for this deployment, right? And then the other thing that we need to do is like, it's called AOT cache in Project Layton. So it's a cache, and we need to warm caches. So it needs a training run. There are several options how to do the training run. Just start it up to a certain point, do execute tests against it. This is how you basically would start it. You tell it where to put the cache, and then you start your application, and then you perform more or less the cache warming so that the JVM can analyze it and see what you're doing. And then it builds this shared object file, this AOT cache that you can serve your types from really, really fast. So you see that the AOT repository will be in there. And that's not the only thing that we do, but there's also accessors, and that's a thing many people don't know. With Spring Data, we do a lot of object binding and property binding, and to do this efficiently, we use method handles, and for that, we generate dedicated accessor classes so that it's just faster than using reflection directly and call the setters and getters. All right? And that's basically what it looks like. And with AOT enabled, we will go ahead and at build time already generate those accessor classes so that you can then, so that they are seen, packaged up within your application, and then are also served faster from the AOT cache. And now we have to bring it basically all together, like Project Layton with the AOT cache, Spring AOT enabled, and then just start it up to see what this actually does. So I've been using Java 25 here, and the app started on this machine in 0.17 seconds. Very small app, of course, very, very small, but still amazing because remember it was 0.7 seconds with plain Java. Then we did the AOT optimizations. It was 0.5, and now we are down to under 200 milliseconds, which is, I think, pretty amazing because we didn't really change our application or any source code or did any fancy GraalVM compilation. So it's pretty easy, pretty approachable, and if you want to learn more about efficient deployments, how to tweak JVM performance with Project Layton and Spring Boot, I recommend watching this talk by my colleague Moritz. Really great talk, just check it out. And it would be really, really great if you could head over to start.spring.io, give the new bits a try. If you encounter errors, report them to us so that we can make the next generation even better for you. With that, thanks for spending your afternoon with me, and hope you enjoy the coffee break.